let me go over just some basic visualization or just the basic capabilities. So you've got a set of tabs on the left-hand side here. So specimen is where you go to load your specimen. And volume is the main volume rendering portion. So this is doing a volumetric rendering through the data. You have the slice views, so you have the 3 slice views, axial, coronal, and sagittal over here along the left-hand side. If you click these buttons, you can move them back and forth. So if you want the coronal bigger, you can do that, and it moves it back into place. You can also double-click in the view. So if you don't, I'm double-clicking here. You can also see what I'm doing with my mouse by this little icon down here. So if I click my left mouse button, I get that button, right, middle button. If I do the mouse wheel, you can see the little blue indicator there. Sometimes I hold down keys, and you can see which keys I'm holding down here to do things. So if you're ever wondering what I'm clicking to make something happen, you can sort of, take a look at that. So you have the basic slice views. You got the 3D visualization here. It has a histogram of the data. So this is micro CT, so it's like the values aren't calibrated to anything. So if you do a medical CT scan, you'll get a calibration. Typically in medical CT, errors at -1,000. Water is right around 0, and then bone is say at like 200 or so, and then like really dense bone, cancellous bone is much higher than that. So in this case with micro CT, the density values aren't calibrated to anything, so we get really strange values. So these are like negative whatever to some really high positive number. But nonetheless, Checkpoint's able to work with it in this case. So some other views you have is you have a surface view, and what this is doing is it's extracting what's called an isosurface from the 3-dimensional data, and then converting that isosurface into a triangle mesh. And so these are actually individual triangles where if you zoom into these and look at them, you can sort of see the facets of the triangles that are in there. And then in the slice views, you can see the intersection of the triangle mesh with the volume. And so this red line represents where the isosurface came from. An isosurface is effectively the surface in 3D that represents a specific density value. So if you think of a contour map, a topography map of height, and you have the contour lines, those contour lines are an iso line at a particular height, and that's what this is represented in 3D. And so in 3D, instead of a line, you have a surface. And so that's where we get the triangle surface from here. And so this surface represents the exact same density value throughout the volume. That density value in this case is -512 because it's micro CT. It's a strange value. And then you can change. If I hold down Control and I click, I can extract a different surface. So in this case, it's a little bit noisy out here, but it looks fine for these guys. What we'll end up doing throughout the rest of the webinar is going through some of these other tabs, but like this tab is going to show our landmark points, and we have some templates that we can do, and then there's some exporting that we can do. So I'm going to go back to the volume view and cover some more of the basic steps here. So brightness and contrast, what I'm doing is I'm left clicking, moving up and down, and then you can go left and right. And what it's doing is changing these numbers that are called width and level. These terms come from the medical imaging side of things, where width and level are equivalent to brightness and contrast. And so you got to sort of play with these to get something that renders your data the way that makes sense to you or makes sense for the data. So you want to move these up and down and left and right until it looks good. And because the density values change for stuff like micro CT, it may be different for each one. However, if you have a bunch of scans that are, you're loading for your data, you can actually set default values. So in this case, I have a view, and I can do set default value, and I can put values in here. So I could say, look at the width and level here, so 3884, 1127, and then I could put those values in here so that the next scan that I load uses those values as the default. So that's a way to get the rendering to match what you need to do.